Hi, everyone. This is How to Get Through EV Tech Inspection. My name is Simon Cohen. Before I begin the presentation, I'd like to remind you while watching this on YouTube, please consider liking this video, sharing it with someone who might find it useful, and subscribing to the SAE Detroit Section YouTube channel. You can find other past presentations related to the Formula SAE competition on the SAE Section Detroit Section YouTube channel. You can also follow the Detroit Section on LinkedIn, Facebook, X, formerly known as Twitter, and Instagram. Um, the SAE Collegiate Design Rules take precedence over the workshop presentations, including this one. No matter what I say, it will be overruled by what they say at competition. A little bit about me and my background. I was part of the Cooper Union Formula SAE team from 2015 to 2019. If you don't recognize our car, and if you're old enough, you may recognize our car after it was rolled in acceleration in 2018. I was team president in 2018 and powertrain lead in 2019. I work as an electrified powertrain design engineer at Roush, doing work that is not so different from the work that many of you are doing on your cars this year. I have been a tech inspector since 2020 and a design judge since 2024, focusing on powertrain and systems integration. As a treat for agreeing to sit through almost an hour of me talking, here's a picture of my dog, Banana. So what's coming up? We'll do a quick review of what technical inspection is, specifically EV powertrain, mechanical inspection, and then we'll give a rundown of mechanical tech inspection for EV powertrain in more detail than you've ever asked for. A little bit of motivation for this, the competition that you're competing in while involving cars, engineering, and racing. It is, at the end of the day, largely a project management competition. These days, as shown here from 2015, these are the June 2025 competition. This is what maybe an ideal scenario would be like. We can start at the end. Saturday, we save for racing, which means Friday, we're finishing our dynamic events and getting design feedback. Thursday, we're starting our dynamic events and doing our design presentation, which means that Wednesday, we have to crush tilt and brake, which leaves Tuesday to pass tech. Now, this is all well and good. If you don't pass tech the first day, hopefully we can pass it the second, but as you can see, we start to lose our opportunity to get through our scheduled events. Worst case scenario, you might find yourself coming Tuesday to tech, you come back Wednesday for tech, you come back Thursday, you do tech and design, and Friday, tech and design feedback. And if you come back Saturday, you'll be watching endurance. Now, what is technical inspection? Also known as scrutineering. It is set up as a filter to ensure a few things. First of all, safety. Most of us have been in your shoes, and we know what happens when something is due before a test day and the solution is figured out on Friday night. We also have to make sure that the cars don't endanger you in any way that we can conceive of. Secondly, as competitors, you guys are all signed up to play by the rules. Someone has to make sure that both you and your competitors are actually playing fair. Now, this process of filtering out the unsafe and the unfair involves a group of volunteers, like me, poking and prodding around your car with a checklist in hand. Now, it is very possible to have a car that passes tech inspection in one go, quickly and easily. Sometimes it takes a few hours at the first try. Usually you get sent back. Now, who are we? We are all volunteers, mostly, but not always FSE alumni. Now, a quick overview of the actual process of going through tech. Tech is going to be for the EV event, it's going to be like an assembly line. You start at one end, you go through each stations. At each station, you will be teched on one particular aspect of the car. So one or two stations, usually at the end, will be EV powertrain tech. This is where I will be. I will have seen all of the powertrains of all of the cars that have come through that day. So let's talk about what you can do now to make sure that you breeze through tech inspection. This is general advice, not necessarily specific to powertrain. The best advice is to give yourself a buffer. Don't build to the edge of the regulation. If you're close or you're barely over, it will take extra time during tech inspection to figure that out. If you build to the line today, you will likely be over on the day of competition. If the rules say that you need an inch of clearance, please give yourself a little bit more. Now, be extra vigilant and extra critical. You can always do the inspection yourself and see what parts pass and what parts fail. It's common to have alumni come in and help with the inspection checklist. We all know that alumni can pick apart their team's car like no one else. Make sure you package things out in the open if it is under a cover. Please make sure the cover is clear or it's easy to take off. And lastly, be prepared. Please take this opportunity now, today, buy new bolts, buy new nuts, buy new safety wire, buy new drill bits, gaffer tape, headrest foam, whatever you need, buy it today. Now, on the day, how to make your tech inspection easy. There are a few small things you can do to have an easier time. First one, clean the car. No rocks, no wrenches, no raw edges. Now, I'm not telling you to trick the judges, but we are all people, and we are more likely to believe that you followed the rules if you look like you put in the effort to follow the rules. Now, again, make sure everything is visible. If you have a cover that's attached with 4 nylon lock bolts, it's going to be really annoying for you to undo them all, and it's going to be really annoying for me to watch you do it. Now, make sure you know what we need to find. Don't send your 4 newest freshmen with the car to tech inspection. This is kind of the paradox of tech inspection, that the more stuff we find, the more stuff we find that's wrong. Now, this is pretty simple. This is just the more time we spend looking at your car, the more time we're actually going to find other things that need to be fixed. This means you want everything to be obvious, not just correct, but obvious. Technically, we're not allowed to let you fix anything in the inspection line, but as we'll see later on, there are some things that just maybe don't get picked up the first time. And if by the time I turn around, a label has been applied where I surely must have missed it the first time, that is considered kosher. Now, tech inspectors are people. They may be showing up crabby, underslept, or after sitting through 2 hours of annoying traffic, just like you. You can always improve your chances of speeding through tech by making them like you. Firstly, don't smell. We're going to be in really close proximity. A can of deodorant and a bottle of mouthwash, about $10, and it will be a key investment for competition. Don't argue too much. By all means, please push back when you think you're being unfairly maligned. But it's usually a lot faster to accept it, fix it, and then come back than it is to argue for 10 minutes, miss getting all of your other stuff checked, and still have to go back and fix it. Lastly, please, 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 please cut your zip ties flush. I'm sure you have all had the unfortunate experience of getting snagged on something sharp in your car. Think about how infuriating that would be if that is not your car. I'd like to talk about what I'm calling the tech inspection range of outcomes. So we are given a checklist with check boxes. It's binary. You either get the check or you don't. The actual cars are never that easy. Things will fall on a spectrum from obvious pass to obvious fail, starting with some things that are just immediately and visually obvious. I can look at the checklist, look at the car, it's right, check. There's some stuff that's correct. It's a little unclear. Maybe it's hidden. Maybe it's, it's a little close. I have to pull out a tape measure. And then the things that take the most time, are the things that are not strictly correct, but they're safe, they're minor. These are frequently the source of arguments. This is an escalation to maybe the chief technical officer. Um, this is kind of the area we want to stay away from. This is why building in that buffer is so important. Then, of course, there's incorrect, but it's unclear. We still have to take that time to figure it out. And then another quick one, immediate and visually obvious. We really want to stay at the top of this. So the first item on my checklist is the TSMP. What is it? This is the tractive system measuring points. These are used for electrical tech after you pass mechanical tech. So we won't be plugging anything in. It's got to be in the right location, has to be hand accessible, has to be look right and be labeled right. Um, ground measurement point also has to follow some rules. Now, you'd be surprised how big of a hurdle this can be. Some things that I've seen go wrong, the wire color, the jack size, the jack's not being shrouded. And weirdly, the biggest hurdle I've seen teams face is just not labeling them. Um, this is one of those things where, again, it'll take 3 minutes to solve in competition. It'll take 30 seconds to do it now. Um, here are a few easy slam dunks. We will be checking your high voltage gloves. If for whatever reason you like using a pair that is out of date or not in good condition, please leave them in your pit. Do not bring them. We do not need to see you use them. We just must see that you own them. We will be asking what kind of coolant you run. If you use water, say water. If you use oil, say oil. If you say anything else, you will not get your tech sticker. I'm not taste testing your coolant, so this will be done on the honor system. If it becomes clear that you're not using pure water, that's pretty easy to rectify. High voltage stickers are easy enough. In all of the years that I've volunteered, we have had them to distribute for free. However, as discussed earlier, this is really easy to do now, and it will just suck up some of your minutes at competition. Now, catch cans. Why do we enforce catch cans? It's for safety, it's for sportsmanship. We can't have slippery liquids all over the race course. They have to be of a certain size. They have to keep oil and water separate. They have to be temperature rated. They have to be in a specific location and follow other specifications as well as certain systems need them. You have to be able to demonstrate the two big things to me is how big is your container and how hot can it get without melting. Um, let's talk about Nalgene bottles. We are told at Tech training to specifically focus on Nalgene bottles. Yes, they're big enough, and yes, they're temperature capable. But if you cannot demonstrate that to the tech inspector, you should not be getting your tech sticker. Okay, so the manual service disconnect, or as it was previously named, the high voltage disconnect, is a safety device, basically only to be used in the event of a crash. If your car has trouble, they need to be able to break the high voltage battery circuit. Because of this, the rules are pretty simple, but there's really no leeway. This is not a great place for creative interpretation. This is one of those areas that is really easy to get right early on and is really hard on the day of if you don't have it. Has to be labeled, it has to be accessible, it has to be, again, above the ground, accessible. The way to read these is really if someone who has never seen your car before has to be able to figure out what the MSD is and pull it if your car is on fire. So one of the more exciting checks that we get to do is checking that everything that propels the car forward lies within the rollover envelope. Now, this is everything except for outboard motors and their associated wiring, and it cannot be below the chassis. Now, usually and hopefully for everyone in this room, the easy part is that all of your hardware, your inverters, your batteries, your PDUs, your controllers lie inside the bounds specified by the rules. What trips a lot of teams up here is the wiring, most frequently the high current wiring. Now, as teams they package their inverter for your best mounting, your motors for your best power delivery, and everyone has forgot that a 25 millimeter squared wire can have an unfortunately large bend radius. Now, give yourself some extra space now. Make sure all of these wires are within that rollover envelope. Otherwise, please expect to bring some zip ties with you so you can secure it in place. Now, the wiring you use for this must convince us that it's not going to fail and it's not going to cause harm. All your tractive system wiring must be orange, and orange cannot be used on non-tractive system wiring. It has to be shielded from damage, and it must have strain relief. And you cannot run your tractive system wiring and your low voltage wiring in the same conduit or connectors except for interlock connectors. Now, these wirings, you cannot be able to touch the conductor with a 100 millimeter by 6 millimeter probe. This is a stand-in, of course, for a finger. Using only electrical tape is prohibited. Again, that's one of those things. Buy the right stuff now. Very easy, inexpensive. If you're the day of and you don't have electrical heat shrink, you don't have a heat gun, this is going to make your life a lot harder. For outboard wheel motors, now, has anyone watching seen either their team or another team face partial or complete suspension failure? This happened in 2017. This rule is so that your shutdown circuit opens if the wheel assembly is damaged or knocked off of the car. We need to ensure that your HVIL opens in the event of the wheel actually coming off the vehicle. I will be quite harsh on this. Others may be less so. The main thing about your HVIL is it has to be convincing. We'll go through a little bit about this next. There are really only two different methods that I've seen for this. One is opening the circuit by either unplugging a connector or actually ripping the pins out. The other is designing the HVIL wire to be cut, sheared, or snapped in the event of a crash. Now, however confident you are, a diligent tech inspector won't just take your word for it, so be prepared to actually defend your work. If you are looking to take advantage of depinning a connector, many crimps have a known pull-out force. It's actually specified usually in the engineering drawings or manuals of many connectors. Here on the right, you can see the force required to depin a Deutsch Autosport connector, which is very popular. And again, for shearing the wire, a 22 gauge wire can probably be broken by hand. A 28 gauge wire can be broken if you drop it wrong. Please find a reasonable source for this information and be prepared to show your work. Major issues that we see during tech, the HVIL is loose, unconvincing that it will actually open in the event of failure, or using inappropriate plastics. Fishing line, etc., will soften, it will weaken, it'll stretch. One of the more time-consuming checklist items can be your grounded low voltage fusing. Now, all of your wiring must be protected with a fuse that is less than or equal to the ampacity of the wire itself. This can be really time-consuming to tech. And not only does this apply to wires, but also to any PCBs that carry your GLV power and the traces in them. So please be able to give us the ampacities of your PCBs. Usually we recommend having like a spreadsheet or a printout, a document that you can bring with you. These are the big things. You need to be able to demonstrate your fuse rating and your ampacity of the wire. This is made easier for you frequently and much easier for us always by having a centralized fuse box. Now, let's go a little bit through what fusing actually is. There are three basic levels of current flow in an electrical circuit. There's the normal load, nominal load. This is what you design for. There is the overload condition. So this is sometimes a little bit extra load if you have a large inductive component, maybe a motor somewhere in your circuit. And then there's the short circuit condition. This is, 10 to 100 to 1,000 times your normal load. Short circuit, or sometimes they're called fault scenarios, are never within design intent and they will always result in failure, usually due to thermal loads, but sometimes due to electromagnetic loads. Now, fuses are actually designed specifically, usually to prevent short circuits or faults, and very rarely to prevent overload currents. We can walk a little bit through an electrical overcurrent failure. So at time zero, your failure occurs, causing a current spike. The current will increase rapidly until you get this catastrophic component failure. The actual current carrying capacity of the component that's failing will start to decrease. This will be material melting, this will be arcing, sparking, degradation. Now, it will eventually open a gap and arc across that gap. Because the arcing is damaging, it'll continue to widen that gap and allow smaller and smaller amounts of current. And then eventually the current will be fully open, some component will be fully melted, and no further current will flow. And then if you put a fuse in there, you can have a failure that occurs causing a current spike, and the fuse will melt way before anything else, and the circuit will open safely. So let's talk about infamous critical fasteners. These are bolts so identified such that if they were to fail, catastrophic or potentially dangerous events could result. Now, unsurprisingly, your battery falling out of the middle of your car in the middle of a race could have catastrophic and potentially dangerous effects. So we make you jump through some hoops to prove that these kind of bolts won't fail. They have to follow specific rules. What kind of rules? What do we need to make sure these bolts won't fail? We need to make sure they're strong enough. This is both grade and form factor. This is the head shape. Make sure you can actually apply the torque safely that you're intending to use. Length, these have to be 2 threads past the nut, as well as anti-rotation or positive locking features. Now, I think adequate bolt length seems like it makes sense intuitively, but why is 2 threads the right number? Why not 5 or 10 or 20 threads? This is because you're using almost always rolled bolts. So bolt threads are rolled, which means that the first 2 or 3 threads are allowed to be, and frequently are, imperfect. This is not always a bug, and frequently these partially formed threads are a feature. They assist in locating and starting the bolt properly to avoid cross-threading. Now, if these imperfect threads are not outside of the bolt, outside of the nut is not being used as designed, and we actually can't assume the performance of the joint. Now, if we look at the cross-section of a nylon lock nut, the locking feature is right at the top of the bolt. So that's right where if your bolt is flush, that's right where your 2 threads are. The nylock might not even deform. So that's why we require those 2 threads past. Everyone's favorite, safety wire. The fundamental idea is that the wire holds the bolt from rotating. Now, how do we accomplish this? First, the bolt head needs a hole in it. You can do this yourself, or as we've mentioned previously, if you have the foresight, you can buy them pre-drilled from McMaster, Aircraft Spruce, or a number of other suppliers. The wire should be wound in such a way so that if the bolt were to come loose, it would have to increase the tension on the wire. For a right-hand threaded bolt, this would look like a Z. The wire should be twisted to be taut. Not that we will be testing your tension, but it should be visible. And lastly, please fold the sharp end out of harm's way or cover them with tape. Now, often Minor errors will still pass deck inspection. We are not requiring aviation grade safety wiring, but it will behoove you and it will behoove a lot of us if you do it correctly. Um, and lastly, it's generally not recommended to safety wire a bolt that is retained by a nut. If something were to induce the rotation of a bolted joint and the bolt itself, but not the nut, cannot rotate, you may or may not be facilitating the opening up of that joint. Now, we get to inspect your high voltage connections. Now, most off-the-shelf electrical connectors get a free pass as long as they pass the smell test. The thing we are really checking here is your bolted connections. These are usually, but not always, between or to bus bars or at a junction point. Now, the bolted connection must have positive locking, but notably, these are not technically critical fasteners. Now, soldering is not allowed in the high current path. The important information behind many of the bolted connection rules is that the current must pass from conductor to conductor rather than via the bolt or an intermediary like solder. I'll dig a little deeper into the theory behind bolted joints and why it's such a big deal. In an ideal world, the metal-to-metal contact between two flat pieces would transmit electricity across the entire surface that's in contact. Now, unfortunately, as many of you may be aware, we are forced to live in the real world, where when we zoom in far enough, neither piece of metal will be smooth, especially if it's spent most of its days in an FSAE garage. This means we must rely on very small areas of current of contact called asperities to carry all of the current. Now this means resistance will actually be much higher than predicted. This becomes a potential area of very high heat generation. Besides thermal failure of nearby components, this may also lead to the failure of the bolted connection, which may in turn increase the resistance. This effect is decreased by forcing the two plates together. Now, luckily for us, this will get better over time. So it is important to properly design your bolted connection. Thank you. Please remember to join us for the next event by going to the saedetroit.org webpage. If you're watching this on YouTube, please remember to like this video, share it with someone who might find it useful, and subscribe to our SAE Detroit section YouTube channel. Have a great day, everyone.